Welcome, everybody, to the latest episode of Star Cells and God. My name is Fuz Rana. I'm a biochemist and a Christian apologist, and I'm joined in studio today by Dr. Hugh Ross, who's an astronomer, a Christian apologist, and the founder of Reasons to Believe, which is the organization that sponsors this program. Today, we're going to be talking about two discoveries at the frontiers of science that have implications for the Christian faith. Hugh is going to be talking about sputtering in the Martian atmosphere and what that tells us about the design of Earth and the necessary role a creator must have played in creating the Earth itself for life. And I'm going to be talking about the identity of the Denisovans, these mysterious hominins, and what this work means for the idea that human beings bear God's image. You don't want to miss this conversation. Well, Hugh, it's good to see you here in studio. When we're recording this, you've just gotten back from about 10 days of vacation. Is that right?
Well, 8 days of vacation. I was also speaking at the American Scientific Affiliation Conference. That was in Denver, but it's like, hey, we got friends who've got a place where we can stay in the San Juan Mountains of Colorado. So, yeah, we just got back from the mountains, took some great photos, posted them on my social media. For me, hiking in the mountains is a spiritual renewal experience. Just seeing the animals, seeing the scenery. It's so different from getting down in front of your computer in the office.
Yeah.
I don't know about you, but I kind of need that break once in a while.
Yeah. Well, you know, my wife loves to garden.
Mm-hmm.
I'm not a big fan of it, but I actually do enjoy going out under her auspices and doing work in the garden in our yard, because there's just something great about being outside and interacting with the beautiful creation that God has made.
Well, in case the viewers aren't aware, your wife's vegetables are the best. I mean, I've had the joy of experiencing some of them. It's like, boy, you can't buy anything like that in the store. So
I'll let Amy know.
Yeah, let Amy know that.
Okay,
she's
well,
at the top.
So I don't think people are watching this podcast to get gardening tips. So maybe, Hugh, why don't you go ahead and start us off with the discovery that you want to talk about involving sputtering in the Martian atmosphere.
Well, this is the first time that astronomers have been able to make a direct measurement of atmospheric sputtering. You know, they've had theoretical models where they kind of take the physics that they know exists in the atmosphere of Venus, Earth, and Mars. But there's a satellite orbiting Mars. It's called the MAVEN satellite. Of course, that's an acronym. The acronym stands for Mars Atmosphere and Volatile Evolution. And, of course, they shorten it to MAVEN. But what's interesting is it's orbiting at 250 to 400 kilometers above the Martian surface. And that's where you'd expect sputtering to occur. And so they took 9 years of data that MAVEN has been collecting as it's been orbiting Mars. And what they noticed in that data is that they saw a significantly greater loss of argon 36 compared to argon 38. And they were able to use that to measure the rate of sputtering in the current Martian atmosphere. I mean, it's standard physics. You'd expect the particle radiation from the sun to strip away the lighter isotope more rapidly than the heavier isotope. And because argon's a relatively heavy gas, they got a more accurate measurement than they could get, say, with the oxygen isotopes, or carbon. And on this basis, for the first time, they had a direct and reasonably accurate measurement of the current rate of sputtering of the Martian atmosphere from the solar radiation and particle radiation. And what surprised them is the sputtering rate came out 4 times greater than what all the models that have been published in the scientific literature had predicted, which basically telling us that the energy in these solar particles is greater than what they thought. And this, of course, and they also noted that when there's a solar storm, you see significantly greater sputtering. And this is what the models did predict. The models predicted that with a solar storm, the sputtering rate would go up. And so it gave them confidence. Yes, what we're measuring here is real. It's actually 4 times greater than what anybody thought was before. And this has 2 significant apologetics implications. There's a lot of speculation by Christians and non-Christians about, was there life on Mars when it was warm and wet? I mean, it began with an atmosphere thicker than it has today, predominantly carbon dioxide. Carbon dioxide is a greenhouse gas, and so that would trap heat from the sun, which would melt the ice that Mars accumulates from comets.
So this would be about 4 billion years ago.
4 billion years ago, and there's a lot of evidence from the Martian orbiters and landers that Mars indeed at one time was warm and wet. But what's interesting from the Martian landers, it indicates that the period when Mars was warm and wet was very brief. It became very quickly cold and dry. Well, the sputtering measurement affirms that, that given the sputtering, and now that we realize it's 4 times higher what we thought, it tells us that indeed Mars would have transformed from being warm and wet to cold and dry very quickly.
The sputtering would have presumably been greater earlier in Martian history?
About 100,000 times to a million times greater. Yeah, so right now the sputtering from the sun is at the minimum. And what happens with the sun, this is in a lot of my books, is I joke that stars are like human beings. They're unstable when they're young, they're unstable when they're old, they're maximally stable when they're middle age. But where stars differ from humans, humans are stable for most of their life. Stars are stable at a maximal rate in a very brief window of time. So to kind of imagine what it's like for the sun, when it was young, its sputtering rate was like 100,000 times greater than it is today, and it gradually subsides as it goes into nuclear burning. And when it goes through half of its nuclear fuel, it hits a minimum. And then things begin to creep back up. So you get a greater sputtering rate, greater X-ray radiation, short ultraviolet radiation. The flaring rate goes up. And, that's one of the design arguments, is that God put us human beings on planet Earth when the sun was at the bottom of that well, where it was maximally stable in its luminosity, had minimal sputtering, minimal X-ray radiation and short wavelength radiation, which is what you want if you want humans, and especially human civilization. The bacteria can handle a lot of solar radiation. We humans, not so much. And especially if you want a large human population with advanced civilization, the sun has to be at that stable phase. And what I've written in my book, Designed to the Core, there is no star like the sun. We've looked at millions of stars and measured their luminosity stability, their flaring rate. Nothing comes close to the stability of the sun. So with our star, the sun, we're really orbiting the best possible star that we've ever been able to observe. And we're orbiting at the time that's optimal for human civilization. So it makes a point. Our timing, our appearance here on planet Earth was not an accident. We appeared at the only moment. And we're talking a window of time just a few 100,000 years wide that we appear when it's possible for us to flourish and develop civilization. However, what this discovery about the sputtering rate on Mars tells us is that early in Earth's history, the sputtering would have been really significant. Number one, Earth is closer to the sun than Mars. Now, Mars immediately lost its water and its atmosphere got thinned out because it has no magnetosphere. And so lacking, a magnetic core and a magnetic shield around the planet, there was nothing to kind of scatter away the solar particle radiation.
Now, how does the sputtering compare to, let's say, the fact that Mars is less massive than the Earth and isn't able to gravitationally hang on to gaseous molecules?
Well, that would have contributed to Mars becoming cold and dry. because water is a relatively light molecule.
Mm-hmm.
And, Earth has a sufficient gravity to hold on to water. I mean, the problem with Mars is that its gravity is so light and its atmosphere is so thin that the boiling point of water is the same as the freezing point at the surface. And so it's one reason why you don't see liquid water on the surface of Mars today, even though you got ice at the poles. I mean, that ice you see on the Martian poles is a combination of dry ice and frozen water. And the poles, the rotation axis of Mars tilts by plus or minus 30 degrees. And so those poles are temporary, but they keep reforming because comets keep bombarding Mars, and comets are 85% frozen water. That's why you always have ice on Mars. But whenever that ice begins to melt, it quickly goes to a gaseous phase, and because of the low Martian gravity, that water dissipates to outer space. So if it wasn't for the comets continuing to bombard Mars, Mars wouldn't have any ice at all.
Okay, interesting.
So, but Earth is a different situation.
Right.
The gravity is much greater than it is on Mars, and so we have sufficient gravity to hold on to the water. However, that water is subject to sputtering. You get particles bombarding water in the atmosphere. It's going to split the water molecule up into oxygen and hydrogen. The hydrogen is going to dissipate to outer space. And so Earth was at risk of losing its water and its atmosphere. And when you go back, like, say, 4 billion years earlier, this is when the sputtering rate was about 100,000 times greater. And so, today we have this magnetosphere around the Earth. That basically means we're not going to lose water because of solar sputtering, even though it's 4 times greater than what we thought. Our magnetosphere is more than strong enough to prevent that from happening. However, push it back 4 billion years, and now our magnetosphere would not be adequate because of how powerful the solar sputtering was at that time. But this is where the moon comes to the rescue. The moon was formed as a result of 2 rocky planets colliding. I kind of refer to it as a merger, because when Theia hit the Earth, that's when Earth had an ocean thousands of kilometers deep, and that liquid water cushioned the collision. So there was a merger, and the heavy element material went into the Earth, light element material was scattered out. A lot of it dissipated interplanetary space, but the debris wound up forming the moon. So the moon formed as a result of the collision between Theia and the Earth about 95 million years after the solar system formed. Now, because of that collision, both the early moon and the early Earth had a hot core. And because the collision dissipated the light element material, the moon is denser than you would expect, and Earth is actually the densest body in the solar system. So, but both of them would have had a hot liquid iron core. And if you got a hot liquid iron core, and if you can circulate the liquid iron, you get set up a dynamo. If you got a dynamo, you get a magnetic field. If it's a strong enough magnetic field, you get a magnetosphere forming. And both the moon and the early Earth, the early moon and the early Earth, would have had a magnetosphere. And because of how close the 2 bodies are to one another, 4 billion years ago, we're talking like 5 times closer than they are today, their proximity means that the gravity of the moon exerted on the Earth will be stronger on the near side than the far side, and that would cause the liquid iron in the core to rotate. So it'd be circulating. And of course, Earth would have done the same to the moon. So both the Earth and the moon 4 billion years ago would have had a magnetic core, a magnetosphere, and because of how close they were together, the 2 magnetospheres actually coupled. And nothing less than the coupling of the moon's magnetosphere or the Earth's magnetosphere would have prevented the early Earth from losing 100% of its water and probably all of its atmosphere as well. And of course, life would never have happened. And this was published a few years ago, where the scientists basically ended their paper saying, this is a habitability requirement.
Mm.
And that's all they said, but it's the most profound habitability requirement I've seen published in the scientific literature. Unless you have a planet with a moon where they both have a hot liquid iron core, where they're close enough together, and where you got the moon big enough that its mass can circulate the liquid iron in the planet, the star that the two bodies are orbiting will basically sputter away all the water and all the atmosphere. And this is not just a problem for advanced life. Not even primitive life is going to be able to originate and survive without liquid water. And so this is the most extreme habitability requirement that I know of. And this paper basically is demonstrating, hey, it's more extreme than we thought. Because the sputtering of the early sun would have been 4 times greater.
I mean, when you think about the miracle of the moon,
right?
It's remarkable because the moon is doing a number of things to, all coincidentally in order for life to be possible on Earth. So it's not only this idea of bolstering the Earth's magnetosphere, but it's stabilizing the Earth's axial tilt, right? It creates the tidal activity. The list goes on and on and on.
Well, the moon is spiraling away from the Earth, but you're right, that tidal force that the moon is exerting on the Earth is slowing down our rotation rate. And the amazing thing is we got down to 24 hours a day at the moment that the sun became minimal in its deadly radiation. And where it became maximal is luminosity stability. And that's optimal for us.
Right.
I mean, so you got these 2 time coincidences. Our rotation rate became 24 hours a day at the exact time that the sun became most stable in its luminosity and least problematic in its flaring activity. So, and there's other benefits. I mean, one of the things about the moon, it's a massive body fairly close to the Earth. Its gravity and its orbit about the Earth scatters away the light element asteroids and comets, but funnels in the things that are super heavy. And so the reason why we got so much platinum and gold on planet Earth today, you can thank the moon. It funneled in these treasure chest type asteroids and made sure they hit at a time when we weren't here. I mean, like 80% of the world's gold and platinum comes from an asteroid funneled in by the moon that hit in South Africa about 300 million years ago. That's remarkable. So I mean, let's just explore some of the spiritual, and apologetic implications of this, because the idea of all these things happening in the just right way at the just right time really speaks of our planet being miraculous in terms of being able to support life. And of course, this in and of itself should be provocative enough for a skeptic to begin to wonder, is there something more to this than just simply coincidence? Well, 3,000 years ago, King David wrote a psalm where he says, the earth is the Lord's and everything in it. And I kind of look at this paper as giving us yet more evidence that what David said 3,000 years ago is true, but true in a way that's way beyond what we can imagine. And the level of fine-tuning, multiple fine-tuned designs tells us this isn't something that's accidental. This isn't something you can attribute to a materialistic worldview. There has to be a mind that's behind all this that explains why the Earth happens to be the way it is. And we're here at the best possible time in the history of the solar system.
Yeah, well, I always think of Isaiah 45:18, right?
Yes.
That the God created the earth with the intent of it being filled full of life.
Right.
And so this is, part of that, those types of scientific discoveries that seem to affirm that passage of Scripture.
Right. So we're talking about a personal God that really does love all the creatures here on the face of the earth, and we human beings in particular.
I don't know if you remember, I won't use the person's name, but there was somebody years ago when I first had started with Reasons to Believe, who was a faithful listener to our old radio show, Creation Update.
I remember, yeah.
And, this guy had lost both legs because he had raging diabetes, I believe, and they were amputated, and was prone to depression, and was even thinking about committing suicide. And he said that in letters to us that when he began to think about all that God had done specifically so that Earth could support life and could support human life, he saw this as a God who was intimate and a God who must care for him deeply. And that not only that took him out of his depression and really, I think, gave him a new lease on life.
Well, I know who you're talking about because he's very active on my social media pages. He's become quite a student of Scripture and science, and I'm so thankful for him because he answers a lot of the questions that get put on my Facebook page before, and he always gives the best possible answer. So, yeah, I thank God for him.
Yeah, good.
Yeah. Well, tell me about your discovery.
Yeah, well, I'm going to lead into the discovery with a little bit of a gruesome observation, but it helps, I think, people understand what's happening with this work. But, I think most people are familiar that sometimes there are these horrific accidents, like a plane crash, let's say, where the human remains are so badly damaged that it's impossible to do adequate identification. And in those cases, thanks to advances in molecular biology, people are able to isolate DNA samples and then compare those sequences with the sequences of DNA taken from family members and are able to use that as a means for identification. And it was this very same principle that a research team from China used to analyze ancient DNA and actually ancient proteins from a skull called the Habron skull, or nicknamed the Dragon Man skull, that was found in China and dated about 146,000 years ago. And based on the fact that this skull has unique features, meaning that it's not a modern human and it's not a Neanderthal, suggested to the Chinese researchers that this must be a new species they called Homo longi. And they began to speculate that this may actually be one of these mysterious hominins called the Denisovans, and by DNA analysis and protein analysis determined indeed this was a Denisovan. So now we actually have fossil evidence for the Denisovans. We know who the Denisovans are. Prior to that, our only knowledge of them was from ancient DNA isolated from these.
Didn't they find a bit of a finger of one? But
in a molar in a cave in Russia, the Denisova cave in the Altai Mountains, and they were able to not only create a high-quality mitochondrial genome, but also a high-quality nuclear genome as well for the Denisovans. And there's been some other fossils that have been found in Tibet, in Taiwan, in Laos, that are not descriptive fossils. They're pieces of bone. In some instances, they're not even sure what the bone actually is, other than it's human or a hominin bone. And the DNA analysis of those indicates that this too is a Denisovan. So we had an idea of the geographical distribution, but there was no fossils that clearly said this is who the Denisovans are until this particular discovery.
Now, all these different finds, Taiwan and so forth, are they definite that these are Denisovans?
Yes.
They are.
Yeah.
So this really extends the range of the Denisovans.
Right.
I remember reading where they thought it was just southern Siberia and that was it.
No, yeah, it looks like most of Asia, right? Mm-hmm. Siberia, Southeast Asia. And in fact, there is evidence that the Denisovans interbred with some human people groups, modern human people groups. And one of the greatest Denisovan contributions are in people from Papua New Guinea. So that gives us a sense of the geographical distribution of the Denisovans. But now that we know who the Denisovans are, this is, really interesting and exciting. Number one, from just a scientific perspective, it just gives us a deeper insight into the natural history of the hominins. It's a much richer, more complex history. But for us, at Reasons to Believe, this is really interesting because this now gives us another opportunity to put our human origins creation model to the test.
Now, am I right that this is the first time they found a major part of a skull, or is it the first time they found a skull at all?
Yeah, well, I actually have an image of the Habron skull that we can show the viewers. And so it's actually a fairly complete skull.
Wow, it really is.
You know, there's a very interesting story about the province of the skull. It was actually turned over to scientists. I can't remember the name of the university in China now where the scientists were, from somebody who was a farmer, I believe, who said that his grandfather had actually discovered the skull in the 1930s and hid it in a well, and they had rediscovered it and thought that they would turn it over to the authorities. People question the story, but we don't really know anything about where the skull was found, anything about its province. But very interesting.
So just to clarify, is this the only Denisovan skull that's been found?
To date. But this is probably going to open up a floodgate of discoveries where people are now going to go back and look at skulls that were very difficult to classify and see if they can show anatomical connectivity to this Habron skull. But the researchers actually used mineral deposits in the skull to try to get an idea where the skull would have been actually buried by comparing those mineral deposits with mineral deposits in reasonable locations nearby. So they think they have a general idea where the skull would have originated, and they can actually do direct uranium-thorium dating on the skull, and they get a minimum age of 146,000 years, probably a maximum age of 300,000, which it puts it pretty close to the time window when we think the Denisovans would have lived. In the cave in Siberia, the Denisova cave, there are multiple layers that have actually given Denisovan remains. Again, these are nondescript bones that have been unearthed, but there's about 6 or 7 that have come from different layers in the cave that span 55,000 years to about 285,000 years. So the date of the skull matches at least the timeline that we get from the cave
you get
in
a
Siberia.
rough match. And again, I think we need to remind people these are not direct dating methods; they're indirect.
Yeah.
So there's big systematic effects, but
Yeah.
it's in the right ballpark.
Right. Yeah, so everything has a measure of uncertainty. That's a really good point. So the way in which these researchers actually determined that this was indeed a Denisovan was through, again, ancient DNA analysis. Now, and the first paper that I have was published in Cell. They actually published 2 papers. And in the first paper, they tried to isolate DNA from the skull itself, and they were unable to recover any DNA. They had this idea that maybe they could actually get ancient DNA out of the dental calculus, which are these mineral deposits that form on everybody's teeth, right? When you go to the dentist to get your teeth cleaned, they're taking off the calculus with that, pick.
Right.
It's not the most pleasant thing. But that dental calculus is a mineral deposit, and it is such a durable mineral that any DNA encased in it is going to have a greater chance of surviving than even DNA associated with bone.
So there was enough teeth in the skull that they were able to get some of that?
Yeah, they were able to get dental calculus. And people in previous work have shown that they could actually get microbial DNA out of the dental calculus of hominin remains. So they thought, why not? And lo and behold, they were actually able to sequence mitochondrial DNA from the dental calculus, and that mitochondrial DNA matched Denisovan DNA, and it was most closely associated with older Denisovan mitochondrial DNA. So the DNA that was from specimens that were about age dated about 285,000 years. They then did published another paper, and I've got an image of that paper, where they were trying to determine if they could confirm this result from proteins isolated from the skull. And so this is a new area of ancient molecule studies where people are looking at peptide fragments, which are pieces of proteins. And if you can get a sequence, a lot of times that sequence can actually be informative about the identity of the specimen. And so they recovered 20,000 peptides that correlated with 90 proteins that appeared to be authentic, that weren't due to contamination. And these, when they were able to sequence them, those that were diagnostic indicated that they too were Denisovans. So this is really interesting, not only in that we now have an idea who the Denisovans are, but we now see new twists on the techniques that are available to paleoanthropologists to study hominin remains, because it's much more likely that proteins are going to endure than DNA. They're just more durable molecules. And they're going to occur, for example, collagen is going to be at much higher levels endemically in bone than DNA would be.
Right.
So this is opening up another, dimension to ancient molecule analysis. So that in and of itself is exciting. But now that we know who the Denisovans are, now we can do some fun things with regard to our creation model.
Well, for one thing, you got the skull. So the morphology of the skull is going to tell you something. Yeah. Well,
just so people are aware of what our model is, in case they're new viewers to this program. I mean, we at Reasons to Believe are old Earth creationists, and we take the biblical account of human origins to be true. We embrace kind of a traditional biblical view of human origins, that is, Adam and Eve were created by God through God's direct personal intervention, made in his image, that we reject the idea of humans having an evolutionary origin. Rather, we see humans being the product of divine creation, and that every human being that's ever lived comes from Adam and Eve. So we see Adam and Eve as sole progenitors, to use technical language. And in our model, we would argue that the hominins were real creatures that existed, and then went extinct, that they were part of God's creation, but they had intelligence, they had emotional capacities, but they lacked the image of God, and therefore we would expect them to be biologically and behaviorally different, where the behavioral difference would reflect the presence or the absence of the image of God in these hominins. And so, one hominin that we typically use to test our idea are Neanderthals. And it's quite controversial about whether Neanderthals were like us or not. But we would take the argument that Neanderthals lacked symbolic capability, which we see as a diagnostic in the archaeological record for the image of God. Even though the claim is there that Neanderthals made art, made music, had language, there's no evidence that really supports that unequivocally. This is heavily debated, and there's good reasons to think that Neanderthals were cognitively inferior to us and lacked symbolism. One of them is the shape of the skull. Their skulls are elongated, whereas modern humans, which we take Adam and Eve to be a modern human, have globular skulls. And that globularity and a flat face change the shape of the brain, where humans, compared to Neanderthals, have an expanded parietal lobe, expanded temporal lobe, in ways that would suggest that we have higher processing capabilities for language and for math, whereas Neanderthals lack that. There's genetic evidence that indicate that the genes that are playing a role in neural development and cognitive development are different in humans and in Neanderthals. Their expression is different. And there are these brain organoid studies that indicate that these differences are physiologically meaningful in a way that would suggest Neanderthals are cognitively inferior.
Well, Fuz, I've also heard you speak about how we have a genetic distinctive that explains why we have a greater neuronal density in our brain.
Yes.
So it's not just the fact that we have a brain that's big. the neuron density is way greater.
Yes, and the quality of the neurons is superior
Yes.
compared to Neanderthals. This is part of the brain organoid studies that people have done. When we look at the archaeological record for Neanderthals, there's not an evolution of technology. They were on Earth longer than we've been on Earth, but their technology was stagnant, whereas we appear on Earth, let's say 100, 150,000 years ago, and within a relatively short period of time, launch civilization and have a technology that just explodes. So there has to be something different between humans and Neanderthals to explain that difference in trajectory, and that, we would argue, is the image of God and specifically the capacity for language.
But we have a morphology that enables that image of God to be manifested.
Right. So, the identity of Neanderthals helps us to evaluate our model. But now we have the Denisovans. So this is another case study that we can use to evaluate our model. And it turns out that when you look, and I have a diagram that actually shows the difference between the skull of humans, Neanderthals, and Denisovans based on the Hebron skull. And what you can actually see is that there are facial differences between Neanderthals and Denisovans, but that the skull is also elongated like that of Neanderthals.
Very similar shape.
So again, you would make a similar argument about the brain capacity of Denisovans as you would to Neanderthals. There also are genetic differences, and those genetic differences align with the genetic differences between modern humans and Neanderthals. Again, where you would suspect that they didn't have the same cognitive capacity as modern humans. Now, even though we reject an evolutionary view of the hominins, it is helpful to think about their origins in evolutionary terms, because evolutionary biologists argue that there was this ancestral group that gave rise to two lines, one modern humans, one Neanderthals and Denisovans, and that split was 800,000 years ago. Neanderthals and Denisovans split about 400,000 years ago, but you would expect them to be more similar to each other than either of them would be to modern humans, and that's exactly what we see with the Hebron morphology. So this, again, provides us with another reason to think that our view of the hominins regarding our model is correct. And then finally, we can actually go back now to the cave in Siberia, the Denisova cave, and it turns out that when we look at the layers that give us the Denisovans, there are tools in those layers, but those tools are very much like you'd expect Neanderthals to make. There is one layer that shows tools that appear to be symbolic and more advanced. This is at 44,000 years ago. But there's no evidence for Denisovans in the cave at that point in time, but there is evidence that modern humans were in the cave at that time.
Yeah, a lot of creatures will use caves. It's a great place to go when the weather is bad.
Right. So this is another piece of evidence that says, Denisovans likely didn't have symbolic capability. Now, we're at the very, beginning of this whole process, right? So there's going to be so much more to come about the Denisovans.
You've been hinting that we're probably going to get more skull fossils now that this paper's been published. People are going to be looking at it, looking at other remains. Yeah. So once we get a few skulls, we're going to be able to nail things down better. Well,
I think there's going to be a few things that happen. One of them is this is really going to motivate paleoanthropology in Southeast Asia. That's a place where there just hasn't been the same degree of work as there has been in Europe or even in Africa. And so I think this is going to ignite interest in paleoanthropologists really probing the archaeological and the fossil record in this part of the world. In addition to that, there are, as I mentioned earlier, these skulls that nobody can quite classify.
Right.
And so now that you have a holotype with the Hebron skull, you can then make comparisons saying these are likely Denisovan specimens too. Were they found in association with an archaeological record? So a lot of fun stuff is in front of us. But the exciting thing is that this really supports our model. And this to me is significant because our model is really one that not only argues for the inerrancy of Scripture, that the biblical account of human origins is true, but the implications of humans bearing God's image are quite significant. It's the basis for Christian ethics. It is the basis for the gospel. We can enter into a relationship with God because we bear God's image. And it really is the basis for each person having inherent worth and dignity. And the way we should think about ourselves is that we are made, as each of us as individuals, in God's image, and God loves us and cares for us, and that we have a special place in His creation because of that.
Which means we should also value one another.
That's right.
The same way that God values us. Hey, one question. Since they got so much of the skull and they got some teeth, do they have any idea of the morphology of the jaw?
I think that's the case. I don't know. I don't know specifically.
Well, here's the reason for my interest. I mean, you look at Neanderthal, we know quite well what the jaw structure is like. Very powerful jaw muscles.
Yeah.
And it was clear that they were able to subsist on raw foods,
right.
raw meats, as well as raw vegetables. And they spent a lot of their energy consuming that. But when you look at the human morphology, we couldn't survive that way.
Yeah.
We don't have the jaw structure or the muscular muscles in the jaw to do that, which is an indication that we were eating soft food right from the get-go.
Yeah.
Because we had the brain to be able to take raw food and process it. And I'm just curious, are we going to see the same thing with the Denisovans? Clear anatomical evidence that they too had the morphology where they could subsist strictly on raw foods.
Yeah, I don't know if there's a mandible for the Habron skull or not. I just simply don't know. But this is where, again, having the Habron skull is going to be so valuable, because there very well could be mandibles that exist that we could then match, with the Habron skull. So these are some of the fun questions that I think are awaiting answers.
Well, as you know, there's a lot of debate about how closely related the Denisovans are to the Neanderthals. So hopefully we'll eventually get enough anatomical remains that we'll be able to settle that issue.
Yeah. Yeah. So exciting times.
It is indeed. Thanks, Fuz.
Yeah. Well, and thank you so much for watching this episode of Star Cells and God. We want to invite you to join the discussion in the comments below. We really love to hear your perspective on this. And remember to subscribe for more content. New episodes of Star Cells and God release every Wednesday. And we want you to like the video, share it with a friend, and remember, the more that we know about science, the more we have reasons to believe.